Today we're going to review complex numbers and do some other applications of them. So our first couple of problems here are just meant to be a review for other things. So take a look at numbers 1 and 2, and if you haven't had a chance to try them already, pause and try them yourself first, and then come back here and see if you kind of agree with how everything went. So looking at this one here, we have these two different terms here, x plus 1. I'm going to let that be a, and x minus 3 is going to be b. So looking at this, I have 2ab squared, which would be my first expression if I were to plug in a for x plus 1 and b for x minus 3. And then for the next one, it would be minus 3a squared b. So to factor this, at this point, I'm going to look at the a's and b's. ab, and I would be left behind with 2b minus 3a, which means a was x plus 1, b was x minus 3, and so I'm going to continue to plug in x plus 1 and x minus 3 where appropriate, and then I'm going to simplify. So the first one remains x plus 1 and x minus 3. Inside here I'd have 2x minus 6 and negative 3x minus 3, so that would become negative x minus 9. Since these both have a negative, I'm going to take a negative 1 out in front. I have x plus 1. Oop, that looks like negative x. It's just a normal x. So I have x plus 1, x minus 3, and x plus 9, all being multiplied by that negative 1 when I factor that out. For number 2, we want to solve this. And so when I look at this, I notice that there's this squared term. So I want to get that squared term by itself. So I'm going to take my entire equation and say I don't really like looking at these fractions. I'm going to multiply everything by 10 to clear the fractions. So this first expression, 10 times 2 is 20. When I divide that by 5, I get 4. 10 times 1 over 10 is just 1. And 10 times 3 divided by 5 becomes 6. So I add the 1 to the other side, and I'm going to divide by 4. And I get x minus 2 squared equals 7/4. So I'm going to go ahead and I'm going to square root both sides to get x minus 2 equals plus or minus the square root of 7 over the square root of 4, which is 2. So then I'm going to move the 2 to the other side, and since it's not like terms, I'm just going to leave it as 2 plus and minus the square root of 7 over 2. So the new stuff today is going to deal with these application problems. So this first one here is going to deal with the AC circuit, where V is your voltage, C is your current, and I is your impedance. They're all related by this formula, and when this got on OneNote, it changed it. Sorry about that. That should be V equals C times I. So we want to find the voltage if we have the given information. Now, J is how they write the imaginary numbers when you're dealing with physics and everything like that. Okay, so they use J instead of I, but it is your imaginary number. So to find the voltage, you're going to do the C, which is 2 plus 4J, times I, which is 9 minus 3J. So what we're going to do, voltage gives you 18 minus 6J plus 36J minus 12J squared. And the j squared here is going to become negative 1 because it is your imaginary part. So we're really going to combine the 18 and the positive 12 to get 30. And then you do your imaginary part to get 30j when you combine the negative 6 and the 36. So that would be your voltage depending on your current and your impedance. So we also want to review the different powers of I. So looking at this, we have I to the 82nd. So there's many different ways to do this one. I think about what is the closest multiple of 4 to 82. because I to the 80th is a multiple of 2 more. So 80th, I to the 80th power is just going to be 1. And so what's going to be left is that remainder here of I to the second power. And I to the second power is -1. A reminder of that pattern, I to the first power is I to the second power is -1, I to the third power is -I, and I to the fourth power is 1, all based off of your definition of what I is as the square root of -1. Another application is actually finding the absolute value of complex numbers. So z is going to be a complex number. It's going to be whatever a plus bi is. So if you're trying to take the absolute value of an imaginary number, it's not going to work the same as just taking the absolute value of just your normal real numbers. So what you're going to have to do is you're going to have to identify the real part and the imaginary part. So if you identify a and b, then you just plug it in here to the square root of a squared plus b squared. So for this example here, my real part is -1. The imaginary part is 5i, so b is the coefficient for the imaginary part. So the absolute value of this would be the square root of the real part and the imaginary part. So the absolute value of -1 plus 5i should be the square root of 1 plus 25, or the square root of 26. So the other application of imaginary numbers is going to be actually graphing these imaginary or these complex numbers. So on this graph grid here, you're used to seeing the x-axis and the y-axis. To graph complex numbers, what we need to know is we have a real axis and an imaginary axis. The real numbers go with the real axis, the imaginary numbers go with the imaginary axis. And so looking at this, to graph -4 minus I, you're going to kind of treat it as a coordinate point -4, comma, -1. The real number is -4, the imaginary part is -1, so you're going to go left 4 and down 1, and this is the answer to where number 1 would be located. For 5i, the real part is 0. The imaginary part has the 5 as the coefficient, so you're not going to go left and right at all, but you're just going to go up 5. This would be the coordinate point for number 2. The next one is 1 plus 3i, so the real part you go to 1. The imaginary part you go up to 3. So this point up here would be 1 plus 3i. So you are able to graph complex numbers when they're in the form a plus bi. So just be careful, because if they're in the opposite form, you have to write it as your real part first and then your imaginary part. So that's where we're going to leave it off. Your homework tonight is just going to be to complete the rest of the examples in the notes here, so all those problems below. Let me know if you have any questions, and thank you for listening.